Hello folks, how you doing? I hope that you have felt successful in learning the first and second fundamental theorems of calculus, primarily the first fundamental theorem since you use it so frequently. And I hope the homework's gone well. Please make sure to meet me on Zoom and let me help you out if you're feeling frustrated. So what we're going to do first is we're going to directly apply the fundamental theorem of calculus to some problems that you've not necessarily had in your homework. So I'm going to pick some problems from AP exams. Now on this one I want to focus on part B, but to complete part B you actually need to do part A. And part A asks you to find A and B, which you'll notice are the coefficients of x squared and x in the given f of x polynomial function. So we'll go through that because it is a good review of what we've done in the first half of this class. So notice it's talking about a local min at x equals -1. Well, I know that I can tell local mins by working with the first derivative. So I'm going to start out and say that f prime of x equals 12x squared plus 2ax plus b. So I'm just taking regular old derivatives there. Now, I know that if x equals -1 is a local minimum, it must have been a critical value. And I know that critical values make the first derivative go to 0. So that means that I know that f prime of -1 must equal 0 in order for -1 to be a min. So let me plug that in and say, well, f prime of -1 would be 12 times -1 squared, which is 12, 2 times a times -1, which would be -2a, and then plus b equals 0. Well, I can't solve a single equation with two letters, so there must be something that I'm going to pick up on the next part of the problem. So when I go to the next part of the problem, I see that we're dealing with an inflection point at x equals -2. Well, inflection points come from second derivatives. So let me use that information to do f double prime of x. And I'm looking at my f prime of x and saying that f double prime would be 24x plus 2a. And I know the derivative of b is just 0 because b is supposed to be a number, remember. Both a and b are just numbers. So the same reasoning applies here, that if x equals -2 is an inflection point, it must have been a hypercritical value. That means f double prime of -2 would have been 0 in order for it to be a hypercritical value. So let me do f prime or double prime of -2. So 24 times -2 is -48 plus 2a equals 0. Oh, okay, so that gives me 2a equals 48, and a is going to be 24. Awesome. So once I find that a is 24, I can go back now and I can find b. So let me plug in and say, well, that's going to be 12 minus 2a would be minus 48, plus b equals 0. So b is going to be 48 minus 12, or 36. Now what I want to do is write the equation for f of x more fully. So f of x is going to be 4x cubed plus ax squared plus bx plus k. That's exactly not what I told you I was going to do. Let me fix that. I recopied what I had instead of putting in the new stuff I know. So it's 4x cubed. Ax squared will be 24x squared. Bx is 36x plus k. All right, so I'm going to proceed on to part B, which is the part that deals with the fundamental theorem. So I want to do the integral from 0 to 1 of f of x dx, and say that's equal to 32. Well, I know to evaluate the definite integral, I need to find the antiderivative of f of x. So when I look at 4x cubed, I know that my exponent has to go to x to the 4th, and 4 over 4 is 1. Okay, so I've got that first term. When I look at 24x cubed, or x squared has to go to x cubed, and it will be 24 over 3 is 8. So when I go to 36x, I'm going to take that x to x squared, and then 36 divided by that 2 would be 18, and then I have plus kx. The antiderivative of k is k times x. I'm going to take that from 0 to 1, and I'm going to make it equal to 32. Well, that means I need to plug 1 in. So 1 to the 4th, 1 squared times 8, 1 cubed times 8. I think I said one thing and wrote another. 1 squared times 18, k times 1, and then I need to plug in 0. Well, that would be 0 plus 0 plus 0 plus 0. So that was just subtract 0. That's nice. Okay, so now we're down to a pretty simple equation. It looks like 1 and 8's 9, 9 and 18's 27. So 27 plus k equals 32. And now I know that k equals 32 minus 27 is 5. So that's a nice application of the fundamental theorem that has you solving a little bit differently, a little bit different way of doing things. Okay, so here's another one. And this was one where you spring from a table of values. So you're reading your information a little differently. Let f be a function that is differentiable for all real numbers, which just lets us know that we're going to have an f prime of x if we need it, maybe on another part of the problem. The table above gives the values of f and its derivative for selected values of x, and from negative 1.5 to 1.5, which I do see are my left and right x values in the table. The second derivative has the property that f double prime of x is greater than 0. And I think that second derivative information actually applies to part D of this problem, which we're not doing. So when I look at the problem at hand, it wants us to just evaluate the integral. So this is making sure you understand just the first fundamental theorem of calculus, nothing fancy here. So remember, if I want to evaluate a definite integral, I need to do antiderivatives. Well, guys, what is the antiderivative of 3f prime? Would you recognize that it's 3f? And then what's the antiderivative of 4? 4x. And I need to take that from 0 to 1.5. So now let's see how this is going to play out for us. So I'm going to plug in 1.5, so 3f of 1.5 plus 4 times 1.5, and then I have to say minus 3f of 0 plus 4 times 0 is 0, so I'm going to leave that one alone. Now I'm going to look at my table to get f of 1.5. So f of 1.5, it looks like from the table, is negative 1. And then plus, of course, 4 times 1.5 is what, 6? 4 times 3 halves would be 12 halves or 6. Minus 3 times, now I'm going to look at the table again to find f of 0, and f of 0 looks like to me it's negative 7. So I've got negative 3 plus 6 plus 21. It looks like to me it's 27 minus 3 is 24. And there you go. So those are pretty direct applications, not anything too crazy. Now, the next two problems are my absolute favorite on the AP exam, and they are consistently on the AP exam. And you've already had some of these in your homework. I went ahead and started sprinkling them in a little bit so you get used to them. But we're going to do all 4 parts of this particular problem. So let f be a function defined on the closed interval from negative 3 to 4. I do see that my left x is negative 3 and my right x is 4 on the graph, so that doesn't tell me anything new. F of 0 equals 3. Okay, now this is something I don't have on the graph, because I look for 0, 3 on my graph and it's not there, but I realize it's because this is the graph of f prime of x, not the graph of f of x. So now I know I need to be careful. The graph of f prime, the derivative of f, consists of a line segment and a semicircle that's shown. Okay, so on what intervals, if any, is f increasing? So here's my thinking. I know that f of x increases when, now remember, this is where we go back to what you learned in the first half of the class, when f prime of x is positive. Okay? So I'm actually justifying my answer already on this. So I tend to justify first because it helps me frame my thinking so I know what to look for on the graph. So f prime of x is positive means that f prime of x is going to be above the x-axis. And the only place I see it above the x-axis is on the interval from -3 to -2. That's where the derivative graph is above the x-axis. So this happens on -3 to -2. And always use parentheses there, okay? Because you're not saying f prime of x is greater than or equal to 0, just greater than 0. So no brackets in the answer. The other thing to be careful about was when you're taking the AP exam, you've got to refer to the function specifically. So don't just say the function or the graph or it. Always talk with proper nouns. So call your friend John or Sally and call your functions f of x and f prime of x. Be very specific. All right, next problem. Find the x-coordinate of each point of inflection. All right, so to do this, I know points of inflection deal with second derivatives. So I know a point of inflection means that you have points of inflection occur when f double prime of x changes sign, goes from positive to negative or negative to positive. So I need to be more careful in a minute because I might actually have to say positive to negative or negative to positive, but for right now I can be general because remember, since the evidence I have is f prime of x, we need to make sure that that we always come back to talking about f prime of x. Now, remember, the derivative of f prime is f double prime. So if f double prime changes from positive to negative, that means that f prime of x goes from increasing to decreasing. Now, we've got a valid reason at this point because now I'm talking about f prime of x, which again, that's the evidence I always have to come back to. So where does f prime of x go from increasing to decreasing? Well, I can see that the graph is increasing here and then it decreases after that point. So it looks like at x equals 2, I'm going to get a point of inflection. So I've given my reason and the answer. Now, remember, f double prime of x might also go from negative to positive. So now I'm going to be specific and say f double prime goes from negative to positive, and probably I would be safer to write out NEG and POS if I was going to do abbreviations. Now, if f double prime goes from negative to positive, then the function that's one level up from it, which is f prime of x, goes from decreasing to increasing. So now I've got a justification because I'm talking about the graph that's in evidence. So what I'm looking for then is where does this graph go from decreasing to increasing? Well, the graph goes from decreasing and then it turns and increases after that, and then that's it. And there's after that it just goes increasing to decreasing. So it looks like that would be at x equals 0. So those are my 2 points of inflection. All right, the next part. Find an equation for the line tangent to the graph of f, which we don't have, at the point 0, 3. So if I'm going to write the equation of a tangent line, I need a point, which I've got, and I need a slope. Okay? So if I want the slope, then I have to look at the derivative of f at 0. So the derivative of f at 0 is f prime of 0. And guys, look at the graph. All right, remember I've got the graph of f prime. So this 0 comma negative 2 tells me that f prime of 0 equals negative 2. Now you have a slope. So if you got a point and a slope, you can simply say, oh, well, my point's a y-intercept, so I'm going to go straight to y equals mx plus b form. So notice none of these problems are a great deal of work, but you have to be very clear about what you're looking for so you can go ahead, look, and move on. Get it down. And we do need to talk about specifically what kinds of things and what kinds of notation you've got to use to get full credit. So find f of negative 3 and f of 4. I might do one of these with you. We'll see how it goes. Once you understand one, then the other one's similar work. Okay? Now, here's the issue. You've got f prime on a graph. We need to tune in now to this f of 0 equals 3. I want f of negative 3. So here's what I've got to do, guys. I've got to go and start using the Fundamental Theorem of Calculus. And you saw me do a little problem like this where I need to say, okay, I know that I can do the antiderivative of f of x in order to get, or the antiderivative of f prime of x in order to spring myself into talking about f of x. And I know f of 0 and I want f of negative 3. Okay? So I can set my integral up. Well, you might notice already that my limits from 0 to negative 3 are upside down. So I can handle that just with the Fundamental Theorem of Calculus, or I could go ahead and swap them and handle it on the front end by putting them in the right order and adding a negative to the problem. I think I'm going to leave it like it is because it will take care of itself with the algebra. So I know to work the problem at hand that I need to think both geometry and algebra. So algebra-wise, I know that the antiderivative of f prime of x is f of x. And then I need to take that from 0 to negative 3. But I need that to be equal to something. So I've got the algebra side of the problem. I need to use the geometry side of the problem. Well, f of the integral, let me do some work up here. It might be easier to keep it straight. I think I better look at that and say that's the negative integral from negative 3 to 0 of f prime of x. Because when I'm doing the geometry side of things, I've got to be clear on this. Well, guys, on that one, what I know is that would be my area from 0 to negative, or from negative 3 to 0, would be this yellow area and this yellow area. So I need to look at those two, okay? So for instance, I know that here, it looks like the base and height are both 1. So if it was a square, the area would be 1, but it's a triangle, so the area is a half. Here, the area's base and height. Let's see, the base and the height are 2. So 2 times 2 would be 4 if it was a full square. It's only half a square, so it's 2. So now I'm going to say I've got negative, and my area would be a positive 1/2 for the little triangle, minus a 2 for the big triangle. But since I've got a negative in front of it, I'm going to make it 2 minus a half, or 3/2. And I'm going to insert that right here, which you can't see very well. I'll write that in yellow. That make that show up a little bit better for you. All right, so now I know what to make the algebra side equal to on the geometry side. So let me proceed with the algebra. So I'm going to do f of negative 3 minus f of 0, and that's equal to 3/2. So f of negative 3 is what I want. F of 0, remember, I had in the little box there. So minus 3 equals 3/2. So now I've got f of negative 3 equals 3/2 plus 3 would be plus 6/2. So I'm getting 9/2 on that one. So if you feel comfortable on this, you can go ahead and fast forward. If you want to see one more of these, stick with me, okay? And we'll do the f of 4. It's very, very similar, but it might not hurt for you to get a little extra practice. Okay, so again, what I'm going to do is I'm going to set up and say I've got to look at the definite integral of f prime of x, and I've got 0. I want to take it to, I've got f of 0, and I want f of 4, so I want my integral to go from 0 to 4. Okay, so I need to think of both the algebra and the geometry ways of approaching that. So if I look at the integral from 0 to 4 of f prime of x dx, then I would be looking at from 0 to 2. So that would be this area, and then from 2 to 4. And that would be this area. Now, one thing I know is the area is contained below the x-axis, so it has to be a negative area. All right? The next thing I know is that the easiest way I think to find that shaded area is to find the area of that whole rectangle and subtract out the area of the semicircle. But remember, once I do that, then I have to remember that the area is negative below the x-axis. So my rectangle is a base of 4 and a height of 2, so that's 8. And then the semicircle is 1/2 pi. The radius of the semicircle is 2, so r squared would be 4. So I'm getting negative 8 plus 2 pi. 2 pi is 6.28, and so negative 8 plus 6.28 is negative. I wanted to double check that I had done that properly. So I'll say that this is equal to negative 8 plus 2 pi. Now I can proceed on with the algebra. So on the left side, my algebra work is that the antiderivative of f prime is f, 0 to 4. Now, something you can also do on these problems, if you want to pause, work it out for yourself, and then play me again, and you can double check and see if you got it right. And if you got it right, then you don't have to take so many notes because you've already got a good feel for how to do this. All right, I want f of 4. It's going to be negative 8 plus 2 pi plus f of 0. So plus f of 0 would be plus 3. So on this one, I'm getting 2 pi and then minus 5. Okay, so I love those kinds of questions, and sometimes I think they're pretty cool to work out, but sometimes you really have to be on your toes to recognize, oh, it's one of those. All right, so here's a similar question from a different year on the AP exam. Now, this time what you want to do is start out focused right here, all right? So I see that this is the graph of f of x, and then they're describing the function g of x. So g of x is described as the function which accumulates area under the graph of f, okay? I want you to immediately remind yourself, oh, then g prime of x is the derivative of the integral that's given. And hopefully you'll get to where you'll go straight to f of x there. But if you look at it and go, oh, derivative of integral, that's second fundamental theorem of calculus. So it's f of high prime, minus f of low prime. So then you wind up with f of x. So you need to start out with your key information is that g prime of x equals f of x. And that needs to be written on your paper. You can write it in the space for part A, part B, part C, part D, or in the space beside the graph. But they are looking for you to specifically make that connection before you do any work. So be sure to start there. Now, if it asks for g of 0, G of 0 means that you plug into the equation for g of x, so from -3 to 0, of f of t dt. So this is asking you not to do algebra, but geometry. So if I go from -3 to 0, I'm going in the right order, so I don't have to wind up making any negatives of things. So I'm looking at the area of that yellow trapezoid. So I'm going to average my bases. It looks like the base on the left is 2 and the base on the right is 1 times the height. And the height is actually, it's sitting on its height, so that's 1, 2, 3. So that looks like 9/2 to me. Remember, on the AP exam, you can't just write 9/2. It would be considered a bald answer. You've got to give supporting work, or you won't get credit even if you're doing it right. So please be careful there. So g prime of 0 is, remember, g prime is f. So g prime of 0 is simply f of 0. So make that connection. And then how do you find f of 0? Look at the graph. So I see on the graph 0, 1, which means f of 0 equals 1. There we go, and we've got it. All right, so let's keep going. So on this one, we're skipping part B, and it says find the absolute minimum value of g on the closed interval. So I know if I'm going to do absolutes, I do need a closed interval, and they provided one, thank goodness. Okay, so this is where you do the candidates test. And to do the candidates test, you've got to put critical values and endpoints on a t-chart. Well, how do I find critical values? Well, I start by saying if I'm going to find the minimum of g, then I've got to, I'm going to write it like I would have told you in class. If you want to minimize g of x, you start by finding g prime of x. Well, we've already figured out that g prime of x is f of x. Now you need to look at where f of x equals 0 or where f of x fails to exist. Well, f of x equals 0 on the graph at -4, it looks like, at 1, and at 3. Make sure I didn't lose any. Now, is there a place that f of x does not exist? So I can say there are places where f of x would not be differentiable because of corners, but I don't see a place that f of x does not exist. So I don't see any holes in the graph or vertical asymptotes. I don't see anything weird like that. So I think that these are my only critical values. So now what I need to do is make a t-chart, and the t-chart's going to be a bit of work, guys. So remember, you need to put your end x's and your critical value x's. Okay? So we've got to figure out then what gives us the largest g of x value, i.e. the largest area, because g of x measures area. Well, let's do, for instance, g of, I'm going to start with g of 4. I tell you what, because we're about to do a lot of these, let's label the areas on our graphs. So for instance, I think we've already gotten the area of that trapezoid. I think that we said the area of the trapezoid was 9/2. So let me put that on the problem here. Now, it looks like the area of, see if I can get my pen to write where I mean it to. The area of this triangle is 1/2 base times height. So the base is 1, the height's 2, 1 times 2 is 2, half of that's 1. And I think this area is also 1. So it looks like if I add them, they'll cancel out since one's a positive and one's negative. Now, I'm going to say that these two little areas in here are going to go back to being rectangle minus semicircle. So let's see here. The rectangle looks like it's 2 units wide and 1 unit tall. The semicircle is 1/2 pi. The radius of the semicircle is just 1, so 1/2 pi 1 squared. So it looks like 2 minus pi over 2 on that part. All right, and then the area of this triangle looks like it would be 1 times 1 is 1, and then half of that, and ditto for this triangle. That might speed my work up a little bit. So for instance, if I said, well, what is g of 4? G of 4 would go from -3 to +4 of f of x dx. So from -3 to from -3 to negative, if I break it up, -3 to 0, I get 9/2. And then from 0 to 2, I get 2 minus pi over 2. And then from 2 to 4, it looks like those areas cancel each other out, so I'm done. And I can clean that up, of course. 9/2 plus 4/2 is 13/2 minus pi over 2. Okay, so if I plug in 3, then I'm going to do the integral from -3 to +3 g of x dx. So again, from -3 to 0 is 9/2. From 0 to 2 is 2 minus pi over 2. And then when I go from 2 to 3, I add another half. So that looks like 10/2 here, which is 5, plus 2 is 7. So far, this is a little bit bigger than the first g of x value I got. All right, so if I do g of 1, I'm going to go from -3 to 1 of f of x dx. And I just realized this isn't going to be the best way to do it, but I think it's going to be the easiest way for me to fix the mess without erasing stuff I don't mean to erase. That I wrote g in there. So from -3 to 0, again, is 9/2. And from 0 to 1 is going to be half of the 2 minus pi over 2. So half of the 2 minus half of the pi over 2, which would be pi over 4. So 9/2 plus 2/2 is 11/2 minus pi over 4. Okay, so to do -3 to -4, this gets a little tricky, guys. So on this one, you have to realize that my bounds are now upside down. So I need to switch it and say the negative of the area from -4 to -3. So that's negative. Now, from -4 to -3 is this triangle. And so I've already said the area of that triangle is +1, but you have to do the negative of the +1. So that's definitely not going to be it. Same thing when you do g of -5. So from -3 to -5 of f of x dx is going to be the negative of the area of -5 to -3 f of x dx. But do you see that if you go from -5 to -3, you're getting these two triangles together, which their area just cancels out and gives you 0 anyway, so it's -0. Okay, so they do want to see your y values. Now, let me mention something to you, okay? If you're going to do an absolute min, it has to either be at an endpoint or at a local min. It would be at a local min if g of x goes from decreasing to increasing. Well, for that to happen, g prime of x has to go from negative to positive. Now, g prime of x is f of x. So where does f of x go from negative to positive? Well, f of x goes from negative to positive at negative 4. So negative 4 is a local min, it looks like. And f of x goes from positive to, no, I think that's the only other place. So if f of x is going from negative to positive, then we're looking only at x equals negative 4 for real versus the negative 5 and the positive 4. So you're really only comparing those three, but you still need to show the full t-chart in order to snag the credit. So I'm looking for mins, not maxes. And so when I look, negative 1's definitely lower than 0. So right now, negative 1's my answer. And then negative 1 is also lower than 13 halves minus pi over 2 because that would be about 6.5 minus 1.57, so that would be positive. So if this is positive, then here is my local min, so or my absolute min. So I have an absolute min at the point negative 4, negative 1. The absolute minimum value is the y value, negative 1. So you'll pretty much get credit if you do that either way. Don't say the absolute min's at x equals negative 4 and stop, because you will not get credit. You've got to have the negative 1 attached to your answer one way or another.